My name is Olivia Haider. I'm from the Austrian Space Program, and I want to talk about Mars 2013, which will be a mission next year in Morocco, and a Mars analog field mission. Before I start into the talk, I want to explain what the Austrian Space Program is. It's a volunteer space organization led by space professionals. Our focus is doing science projects, but also public outreach and education. And it's an independent organization. We live from project fundings, sponsors, donation, and so on. And I'm happy to have also Alexander Subček and Roberta Batanese from the Austrian Space Program here.
Stand up. Because I don't know.
Next year, between the 1st and 28th of February, we will lead an international and integrated Mars analog field simulation in the northern Sahara of Morocco. See a picture, it looks like that there. This picture was taken this year, February. The field mission is part of our Polaris program. Polaris program is our flagship science program, and the focus is on Mars analog research and on robotic human interaction. We will have a small field crew in Morocco, about 12 people, and in Austria there will be a mission support center which supports the whole mission and helps the field crew there. We are doing this together with the Ibn Battuta Center in Marrakesh, but we have also about 25 partners in the background from various fields like universities, also technological sponsors like T-Mobile Austria, and also Lancom, which gave us all the Wi-Fi hardware, which is very important for us to have the connections. Also the JPL is cooperating again with us with an experiment, or the Space Research Institute in Russia. The mission is designed to be to study equipment behavior. That means doing instrumental tests simultaneously, but also together with human interaction. Therefore, we have the oewf spacesuit. It's also meant to be a platform for testing live detection, testing geophysical techniques, and also a platform for testing rovers there and so on. We want to see if Sahara is also a model region for Mars analog research, and we have also strong focus on outreach as an outreach platform. That means we will spread the word about the mission and give talks, outreach, and so on. We will see. Just the baseline design, how it will work. As I mentioned before, we have the Mission Support Center in Austria. It will be based in Innsbruck. This has a direct satellite link to the field operation, the ops. This will be in the field, and they are the only ones who are allowed to talk with the spacesuit. The Mission Support Center has always an audio channel and can listen what's going on, but they are not supposed to talk directly with the spacesuit. Just imagine if you have a mission on Mars and the Mission Support Center on Earth. If you want to talk to Mars, it takes a lot of time. You need to wait at least 10 minutes that your message is transmitted, and 10 minutes that you get an answer. So it doesn't make sense to talk directly to the astronaut in the field and give him something to do. Interesting is also on the other side we have a remote science teams and a media team in the background. That means the scientists are there and analyze the data in real time. Just a quick overview where exactly it will be. Here is Erfurt. Erfurt is the nearest town to our location. It's in the eastern part of Morocco, 8 hours drive from Marrakesh. The Atlas Mountain is in between, you see here, Atlas Mountain. Morocco is a kingdom, has about 32 million inhabitants, and mostly are living west of the Atlas Mountain. So here is really the beginning of the desert. Erfurt is also known as the gate to the desert. As there are famous sand dunes, it's a little infrastructure there, so they have some hotels. But the people won't have the comfort of a hotel. They will have their own camp in the middle of nowhere. The campaign focus is we want to serve as a catalyst for a series of technological demonstrations of scientific investigations and enhance the visibility of analog exploration in Europe. This is really a strong focus we want to do. Therefore, we invited through our announcement of opportunity international partners to join our platform and to join the mission. A review board then selected 14 external experiments. This will be complemented by some our experiments from the Polaris program. For example, the oewf spacesuit, which you see here. There are also some tests we are doing on her or him, depending to whom you're referring to. And then we have also, see on the next slide, we have 4 rovers or landers and 2 spacesuit simulators. Probably some of you heard already from oewf, our spacesuit simulator, but we will have a second one, which was built this summer. This is called the oewf, and also the little sister of the oewf. And it's not so advanced like the oewf. It doesn't have this complex onboard data system in the backpack, but it has the possibility to do the science. If it's not necessary to involve the oewf, which is nearly completely booked out for all experiments, you have the possibility to do, for example, the contamination experiments also with oewf. The S stands for science. One of the campaign focus is the human-robot interaction. You see 2 examples. On the top, this is the Puli rover. This is a Hungarian rover, GLXB team, a Google Lunar X Prize team, which will join us this time. And down here is the Magma rover. It's a Polish team. This photo was taken at the Dachstein Mars simulation from this year, which we conducted, and they will be again on board. To manage all these rovers and spacesuits, etc., we have traverse planning algorithm, and this also security issues and resources will go into this algorithm, and therefore we can plan who has to be where and when, and what's the optimal thing. Like the oewf can operate until 6 or 7 hours, and afterwards you have to first you have to don. That takes 2 hours, and then you have to doff again. And if you want to conduct experiment, for example with the oewf spacesuit, you have to schedule this. And yeah, we have had a master thesis on that for the traverse planning. Another focus is the remote science support. For example, we will extend the EVA range until 10 kilometers because of the Wi-Fi connection we get. That means we have a lot of space to explore and a lot of places to go. When we go there, we collect data, we collect rock soil samples and so on. This data will go through the ops to the field operations to the MSC, and in the MSC, as I explained before, we have our scientists in the remote science support. This is very important because they will analyze the data, especially for geophysical data. They can give near real-time feedback and also say where should be the next EVA. So is this place looks interesting? We say, okay, next day we want to go there again to take some other soil samples, or they go to another place. And in the end, we want to compare all the data. Like they get all the geological data, and they have to make up how this region looks like geologically. And this we will compare in the end to the ground truth, and this will be also a measure how good we collected the samples. Imagine if we once go to Mars, we want to explore or know how Mars was built up. So it's important to know if humans can do, for example, in 1 month a big area, and if it's possible to get a really good data and knowledge of Mars. This we will do with the comparison to the ground truth. Another part is also the astrobiology thing. Imaging or searching for life means always reducing the contamination risk. No one wants to go to Mars, discover life, and in the end, if you look at it, it's human DNA. That means you had done something wrong. So it's a very big thing is mitigate contamination issues forward and backward. We also have some life detection techniques with us, and also human factors, especially isolation and working under stress. And as I said, a strong focus on public outreach and education. We do have an international outreach team. We have negotiations with documentary filmmakers in Austria and Poland for the moment. And we also have a student-led experiment which was built this summer during a Unicamp. It's a very small science camp, and they have their own experiment there. Our focus will be also very strongly on social media. I have to speed up a little bit. I have 2 or 3 experiments which I want to present because I really like them and I think they're interesting. First one is the media, and I would like to give over to Jane because it's her experiment to explain a little bit.
Hi, so we have a mission concept to go to Mars in the 2020s, and we'll put 20 nano-landers out of the back shell of a bigger mission. And the little small landers will land over 5-kilometre range and detect methane. They'll be dropped in a hotspot we know from the orbiters, and it'll be for a precision location of where the methane might be coming from. So then a main lander or rover could then be driven over to do further experiments on it. So for the Morocco simulation, we're looking to make 3 prototypes based on Arduino technology, just small black boxes, and do the modelling to triangulate if we can detect where the methane source is coming from. So that's basically it.
Thank you, Jane.
Just a quick one, what's the sensitivity? So what's the smallest fraction you can get?
We're still working on that, and we're probably not going to be super sensitive because we have
It's parts per million for the first. Parts per million, but big parts per billion for the main.
Okay.
And this is further from next year.
Another one which I personally found very interesting is this deployable shelter, which is a rucksack-size emergency shelter for astronauts by the Technical University of Vienna. It will be a prototype and tested in Morocco. And another one, because we already saw rovers, we also have a lander, the Hungarian one, is surveyor class lander site, and it will also take some soil samples. Mission Support Center, this is very important. This picture was taken last year during the Rio Tinto Mars simulation. We will have a fully equipped Mission Support Center. This is directing the mission. We will have a flight director, for example Alexander Subček, you see here standing in the middle, in the background, will be one of our flight directors. and he managed the flight planning team, and all experiments are scheduled through a flight plan. So you cannot go to Alexander and say, hey, I want to do that and that experiment. First it has to be scheduled in a flight plan. Flight plan 50 minutes, comparable to an ISS flight plan. We have other teams, as I said before, the MediaCom team, which is responsible for outreach, for social media, for the press, and also a ground support team, which helps us with all the logistics, and of course the science teams. Why are we going to Morocco? Morocco is, well, you see it in the picture, it's very similar from morphology and mineralogy. There are dry riverbeds and deltas, including dunes and sandstones. But I think this picture shows it best. Mars, a photo from Viking, and this is one of Morocco. And if you just don't see it's only the blue sky which is different. So it's for us it's a good model region. What are the next steps? Just a short timeline. We will be very busy until the end of the year. There will be a big dress rehearsal at the beginning of December. That means all the teams come together in Innsbruck and train the suit testers for the experiments, getting to know each other and so on. January will be shipping time. We need to get all our stuff to Morocco, which takes some time, and and then we will start with the prep week, 2nd of February to 9th of February. This will be also the possibility for media teams to come to us and document how we are working on. And until the end of February, it will be science only. We will relocate the camp in the middle so that we have two interesting sites to explore, and afterwards we are planning to do a science conference on the whole mission. Well, I just made the screenshot before. We do have 141 days left and the clock is counting. Yeah, that's it for now. I have a video, a teaser video for you. I know the sound is not perfect, but I tried to show it to you, just to get an impression.
Risk mode under our parachute. Sending.
Signaled Odyssey is still strong.
Sky crane has started controlling.
Signaled Odyssey.
Touchdown confirmed. We're seeing
promote it. The official hashtag is Mars 2013, and spread the word what we are doing. Thank you. So I think we have 2 or 3 minutes for questions if there are some.
Did you look at the geology there in Morocco, how similar it is to Martian plains?
Yes, there are some similarities. I don't know the details, but our geologists know it, and that's why we have some 2 or 3 spots where we want to go, because they are extremely interesting.
Okay, so you showed this nice picture there with black rocks.
Yes.
Those are basals, you know? Basalt rocks?
I think so, but don't blame me on that. Yeah, I have to look it up for you.
Okay.
Yeah.
What will the camp look like? Will it be like a Martian habitat? Or
No, it will be a normal tent-like system. It's not necessary for the mission itself to have a habitat structure. We will have another experiment which will bring an inflatable habitat, but only as demonstration. And yeah. Okay? Yeah. Okay, another question. Last one.
How can we help?
As I said, all can help with spreading out the word, like via social media, promote us a little bit, blog about it, and so on. It might be that we